So how's it, everyone? Come on, we're now on a sort of live event, right? Up until now, we have all been just online. We have been sitting in our pajamas watching a speaker, but now we're live. So how's it, everyone? Wonderful. Awesome, thank you, James. Awesome, awesome, awesome. So welcome. So we are going to talk about ksqlDB, the real-time streaming database. I'm Niels Berglund. You see my contact details there. I work for a company down in South Africa called Derivco. We're doing online gaming, online gambling, call it whatever you want. That's what we're doing. And I am also an Microsoft Data Platform MVP. So that's my kind of my shameless self-promotion. That's the first day when you're going in presenting school, you're learning about shameless self-promotion. You have to do that. That's the rule, right? Cool. So before we go further, session feedback. I know we probably that's where you need to do stuff, right? But session feedback is important because that make both that can make the conference better as well as the individual sessions. So just for that, you should do session feedback. You should also do session feedback because SQL Bits here, these wonderful organizers, they are donating some stuff to National Trust. I think it's saplings to plant a football pitch with trees, I guess. I guess they are planting it up in Manchester United, because they're not doing too well at right now, I've heard. Anyway, so there is a third reason. You can win prizes. So I saw in LinkedIn this morning, SQL Bits had posted a message, a nice picture with someone won a prize because, in this case, she had submitted a session feedback. So every time when you're, let me start over. When you are submitting session feedbacks, you are in the draw for prizes, whatever they are. I have no idea, but they are cool prizes, really cool prizes. So here's the link for this session to the left, and if you're tech savvy, which I'm not, you also have a QR code that you can use. I never understand how they are working, but anyway, I like the link better. I will repeat this one at the end of the session as well, so if you don't get it now, then yeah, whatever. Right. So this is what we're going to talk about. Actually, first of all, how many are SQL Server users here? Well, it's strange that seeing that this is SQL Bits on a data conference. Yeah. How many are using Kafka? Okay, a couple. All right, cool. I just wanted to get the feel for the audience here. So we'll start this session with a Kafka 101, that for you who haven't used Kafka that much, that don't know what Kafka is, apart from a writer, then you get some feeling for what this is. Right? Then we'll talk a little bit about stream processing, because we are using ksqlDB for stream processing. Right? And we'll talk about why we are doing stream processing, etc., etc. And the rest of the talk will be about ksqlDB, the real-time streaming database. Yeah? Before we go further, so I don't know if there is anyone old enough here to, well, except for me, remembering David Letterman, a host at one of these American nightly shows, talk, whatever. He had always a list of X number of the top X number of reasons for something. So I put together, there is a method in this madness here, so wait a second. Right? So I put together the top reasons to attend SQL Bits. Reason number 5, well, learn new things. So that's what you're telling your boss when you want him to pay you to come here, pay for you to come here. I'll learn so much new stuff, so it's awesome. And you will probably also tell your spouse that, hey, I will learn so much new stuff, I will get a raise, etc., so I have to go to SQL Bits. That's reason number 5. Reason number 4, kind of related to number 5, get to hear interesting stuff. This may be stuff that has nothing to do with what you are doing, but it is interesting. Because no matter what, you will hear interesting things. Now, reason number 3, get away from home, right? After 2 years in lockdown, you have cabin fever, you want to get away. So that is a huge reason why you are attending this conference. At least it's for me. So I spent 24 hours in an airplane to get here, so I really wanted to get away from home. Right? Reason number 2, hang out with your brethren. I can't tell you how awesome it is to see face-to-face people you know from pre-COVID, and also see face-to-face people that you have learned to know during COVID. I have an example here, James, sitting here. He's a kind of colleague to mine, and just being able to go up and say how's it is awesome. Anyway, however, all that are good reasons. The reason number 1 is swag. Because you come to conferences to get swag. You go to the various exhibitors and you're grabbing t-shirts and stuff. And then you're coming home and you're telling your mates, your spouse, whatever, look at this very, very cool t-shirt I got. Absolutely free, can you imagine? That you then had spent a couple of $100, pounds, whatever, to attend the conference. That is neither here nor there. So, with that in mind, we have swag. And we have t-shirts, we have notebooks, we have pens for the notebooks, awesome, right? So I normally hand out swag for good questions. Right now, if it's after COVID, I hand out swag for bad questions. Actually, I hand out swag for any kind of question. So that is me bribing you to talk to me, to interact, so we can have some cool communication going, right? Are we good? Cool, right. Now then, having gotten away with that, what is Kafka? Kafka started back in the day at LinkedIn, where they wanted to rewrite their existing messaging system. I have no idea what that existing messaging system was, but they wanted to rewrite that. So some very, very smart peeps, boys and girls, decided that let's write Kafka. We know what we want, it should look like this. And they started writing that. They released it to open source as Apache Kafka back in 2014. And then 1 or 2 years later, the people that wrote it at LinkedIn went away, formed their own company called Confluent, and they are now the commercial arm of Kafka. Kafka is open source, right? And everything we will see here, except for one thing, and I'll tell you what that is actually open source. So yeah, but Confluent is the commercial arm for Kafka. It's a distributed streaming platform. What do I mean with that? We are publishing and consuming events, messages, records, call it whatever, and we can treat that as stream. These messages are persisted, and we'll come back to where they are persisted, and we can then, based upon this, we can process these streams, these records in real time. The thing that they are persisted is a huge differentiator between other messaging systems, where you have to persist it kind of, well, you need to decide to persist it. With Kafka, it's always persisted, and they have very performant way of writing and reading what is persistent, what is being persisted. And it is persisted. We are database people. We love the log. We would be dead without the log, right? Logs are trustworthy. We believe in the log. So and that is not only databases. Anything is log file based. When someone comes to me and says, hey Niels, we have a problem, we have an error here, what can it be? First question is, what does the log file say? All right? And surprisingly enough, not many people can tell that up front. Blows my mind. Anyway, so where Kafka is persisting messages to is to a commit log that sits on the individual machines. And this commit log is now also replicated out over, if you have if you have multiple machines, so let's say you have a 3-node cluster, these logs are replicated out over these 3 machines. And they are, as I said, they are distributed. Cool. Questions so far? Come on, guys. This is swag as prices here. All right. You're a tough crowd. So the ecosystem, just have a quick look at the major components. So we have Kafka itself, which is cool. Let's call it the message broker. We'll come back to broker in a second. So we have Kafka. We have Kafka Connect, which allows you to connect, as the name implies, source and sinks, where you then have connectors that reads from source and pushes to sink, where source can be a Kafka topic. We'll come back to what a topic is. Or source can be some other system. And the sink can be Kafka topic or some other system. But it always goes between a system and Kafka, Kafka and the system. Does that make sense? So if you will hear about Kafka connectors, that's what they do. K-streams is like a DSL on top of Kafka, where you can write streaming applications. We'll talk about that as well in a little bit. Then ksqlDB, the star of this presentation, is a SQL layer across, on top of Kafka. So we can write applications with pure SQL statements. And as SQL developers, that's awesome. We have Control Center. That is the component that is not available in open source. So Control Center is a web UI, and I'll find it somewhere here, that you get when you install Kafka, if you're installing the commercial, the enterprise edition. So I'm running Kafka here on my box through Docker containers, and if you run a single node Kafka, you can run the commercial, the enterprise edition without any problem. So it's kind of like a developer edition. Like in SQL, we have SQL Server Developer Edition. This is, well, Kafka Developer Edition. Right. So here you can do a lot of cool stuff. We can look at topics. We'll talk about that, what that is in a second, et cetera, et cetera. So Control Center is cool. There are other UIs out there, so you don't have to use Control Center. Make sense? Cool. Then, if we're now drilling down into Kafka, where we're talking about the major components about Kafka, we have the cluster, where a cluster, normally when we hear the word cluster, we are thinking about multiple machines. A Kafka cluster can be one machine or more. So even if you have one box, one Kafka box, that in itself is a cluster. We have the broker. This is the dude or dudette that handles the messages that we are sending messages to. We have a topic. That's where we're publishing messages to. Topic is like a table in SQL Server. Right? We are pushing data into this topic. However, the topic is purely a top-level construct where the important bit in the topic are partitions. So remember I said before about the log, right? How the log file is important. So partitions are individual log files. And when we are writing data to a topic, the data ends up on a partition. Yeah? Cool. We have an offset, important, because when we are reading data, we are reading from an offset, which means that I can push multiple messages into a topic, a partition, and multiple people can read these messages without having to duplicate them. So in RabbitMQ, for example, if you want to have multiple consumers being able to read the same message, you need to set up multiple queues, because a consumer reads from a queue, and excuse me, and in that case, the messages are actually duplicated across the queues, so you're getting a much larger volume. In Kafka, you just have an offset. You're saying, I want to read from offset 42, and off you go. Right? Consumer group, yeah, that's beside the point here. That is how you as a consumer can ensure performance. Topics and partitions. Topic, well, like a table name. We have different types of schemas that we can push in there, JSON, Avro, JSON, etc., etc., etc. We have certain properties of the topic where retention is one, i.e. how long do we keep the data in this topic. Partition, we have one or more, where, as I said before, partition is the actual log, and the partition gives me now scalability, performance, etc., etc., etc. And the publisher, so you're setting up a topic with X number of partitions. How do I decide where these which message goes where? The short answer is you don't. The publisher, the Kafka client that publishes the message, is actually deciding where the message goes based upon something in the message called the key. I think we have it here somewhere. Yes, so the third bullet in the topic. So the message has a key. That is the key we're talking about. It's like the primary key in a database. It has a value. Well, that is the message in itself, etc. So the publisher, based upon some algorithms, decides based upon the key where to push the message. And the algorithm is basically a modulus. They are doing a hash algorithm and then doing a modulus on the number of partitions, and based upon that, it's decided where the message goes. Yeah? Are we good so far? Questions? Yes, sir. Finally. I'm an old dude. I can't hear you at all. I still can't hear you.
Does the consuming application maintain the offset, where understand what offset is read? And how does it know? Is that the responsibility of the solution that's kind of consuming that?
Okay, so who is responsible for handling the offset? The thing that handles the offset is the broker in itself. So a message comes, so I'm a publisher. I'm publishing messages to you. Right? I kind of, based upon my code, based upon my key, the message ends up in the left ventricle, or whatever it's called, with you, right? But I don't care, as a publisher, I don't really care about the offset. That's the broker. He sees where is the next empty spot, and that's where he puts the message. From a consumption side, you're absolutely right. The consuming client handles the offset, and he knows what is the last offset I have read, and da-da-da-da-da. Cool. Medium, large, or extra large? T-shirt.
Medium large.
Large. I heard large. I'm pushing this because I'm not taking this stuff with me back home to South Africa. I can tell you that much. What is that? So, of course, it's the last one. Can we pass this back to the, James, can you pass this back to the gentleman? There we go. Cool. Awesome. See, if you ask questions, you're getting cool T-shirts or notebooks, whatever. So, publish and consume. So this is kind of what it looks like. I have the publisher on the left-hand side. He publishes. We have one topic, 3 partitions. The publishing, the client, the code decides which partition to go, and then I am consuming. if we were to do this in the real world or semi-real world, let's go into the control center and let's create a topic that we call gameplay, obviously, right? So here now, when I'm creating a topic, I can define how many partitions, etc., it should have. Right now, I'm just doing one partition because it is simplest. Actually, it wouldn't matter. I wouldn't need to do anything other than this anyway, but okay. So we're creating that. I now should have a topic here that we call gameplay. Awesome. I then have two .NET applications that are publishing and consuming. And we are publishing what we call a game event that has the player ID, game ID, score, event time, and a win. This is kind of made up a little bit. But anyway, so that's what we're publishing, right? Cool. And then I have a the other .NET consumer is consuming. So I'm saying here in the consumption code, what is the topic, and then essentially I am calling consume, and we're going down in a loop, and we're pulling messages, right? So if we were to run this, let's go to here. Actually, let's start with my consumer, and we say on .NET restore. I mean, this is, you have clients for almost any language. I just happen to use .NET because that's how I was brought up, right? The Java client, Java is the native Kafka client, but Java and .NET is fairly much on par right now. At one stage, there you weren't, but they are now, right? Cool. So let's say .NET run. We are ready to consume. How cool is that? And .NET run. So this is now the upper command prompt is for the publisher. Yes, I want to continue. Clicking yes. I have. So if we're seeing now, on the upper hand, we're seeing that I published, and on the lower command, I consumed. So we actually pushed messages and we consumed messages. Yeah?
Is there a notion of a dead letter queue? So if something doesn't get consumed.
Sorry, again?
Is there a notion of a dead letter queue like you would have in RabbitMQ?
Is there a notion of a dead letter queue? Not really. You would need to implement that one yourself. Okay? Huh. And I didn't even have to prompt for that. Awesome. Okay, cool. So we have seen how we are publishing, and we have seen how we are consuming, right? The problem now is that we want to just doing this. Is it really worth something? What do I get out of it? Well, I get to consume messages. That's cool. But what if I now wanted to do stream processing, right? Because I want to do something with these messages. So here, so stream processing is what we are doing. How do we handle messages coming through? And on the slide here, you see a dude, lower right-hand corner, pushing in widgets. Widgets has properties. One property is color, and then in the middle box where the person in yellow stands, that's where we are processing this now and pushes to various other places. So the red goes somewhere, blues go somewhere, green goes somewhere. That's stream processing. Yeah. Here we have a scenario. So we're here, right? We're at my background. We're having slot machines, one-arm bandits, 777. Someone comes and drags the handle. He plays, he bets, well, he's making a bet, whatever, and that now creates a game event. And in our case, from all slot machines, the game events looks like that. No, they don't. I'm just lying to you. But we are creating this game event: player ID, game ID, win, score, and event time. Yeah, that is now ends up on this game event topic in Kafka, and now we are now interested in, is this a potential big win? Because if it is a potential big win, we may want to give something to the player. Or maybe this player has a bad streak, has 5 losses in a row. Right? We want to give the player something. We want to entice the player. Right? We are gamifying the game. Yeah? So a potential big win here is win more than within a time frame. How would we do this? I mean, this is not a strange scenario. All casino operators is doing things like that. So it doesn't need to be casino, it could be credit card. If I try to authorize my credit card 3 times within 10 seconds, something has probably gone wrong. Or if I try to authorize my credit card within 2 minutes from 2 different continents, something has probably gone wrong, potential fraud, right? So we have lots and lots of examples of this. So how would we handle this? Well, we have seen how I can consume. Publishing is not the problem, and we can see how I can consume. So I could roll my own here somehow. However, the problem, what do I do with state? Yeah? What do I do with if something goes wrong, etc., etc.? So yeah, rolling your own can do it, but nah, don't do it. It's a little bit like, doctor, it hurts when I do this. Well, the answer to that is, well, don't do it then. So don't take on a lot of extra work for yourself. So so Confluent saw this, and back in 2016 they introduced these case streams, which is, as I said before, a DSL that allows you to read from topics, write to topics, and have code in between. The problem is that you are still doing, okay, so there are some handlers for errors, etc. That is cool, but you have to write the code. And the code is either in Java or Scala. I mean, Java and Scala is not bad. I'm not saying that, but if we are, I mean, I wouldn't really want to do that, me being a .NET dude. Right. So later on, Microsoft introduced ksql, which sort of builds on top of K-streams, which is now a SQL-like language. And in 2019, Confluent introduced ksqlDB, which is essentially ksql with more bells and whistles. So it's a SQL layer, provides a SQL layer on top of Kafka, and you are writing SQL statements. Fairly much normal ANSI compliant, somewhat compliant SQL statements. Yeah? Allows you to build stream processing applications, and it definitely lowers the bar to write a stream processing application. So something that would take 5, 6, 10 lines of code, which is not much in K-streams, takes 1 line of code with ksqlDB. So something here, right? So we're having a source stream coming into Kafka. Okay, so, sorry, my mistake. So in the middle, right? In the middle here we have Kafka. On the right-hand side, we now have ksqlDB. ksqlDB is a Java process running in a VM, running somewhere as Java code. So nothing more, nothing less. It uses some clever tricks under the covers. It uses the logs that we have spoken about so that if things goes wrong, we can always read back from the log. Right? So we have a source stream coming into Kafka. ksqlDB now reads from this topic because we have set something up to do that. It is doing some processing, and it reads back to maybe another topic. Sorry, writes back to another topic. Right? Then, once again, we can now build data pipelines here, where that result comes into a topic. We have ksql reading from that particular topic, doing more processing, and writing back. And on we go. Right? And then eventually, we have consumers that now reads the results here. Right? Applications like analysis, BI and analysis is probably the same thing. But anyway, you get my point. Cool? Good so far? Awesome. When we're talking ksqlDB, we are mentioning streams and tables because that's what we are working with. So data comes into a topic. Right? That's a given. What we then can do, and now it sits in the topic. No one removes it from the topic. But what we can do now is we can create a stream on top of this topic. So now, as soon as data comes into this topic, this data appears in the stream. Then I can build smartness on top of the stream and write back to a topic or do other things. Yeah? So that's streams. So streams and tables are kind of, there's a duality. From a stream, I can create a table, and from a table, I can create a stream. So they are, interchangeable to an extent. One big difference between streams and tables is that streams are immutable, whereas a table is mutable. So when we're talking about tables, think about materialized views, because that's essentially what it is. Right? Good? Cool. So let's, I am very aware of time. Let's do this. Let's go and write some code. So we saw how I have my how we have my gameplay topic. What we now want to do is writing things to come back to solve that initial problem we spoke about, that how do I capture that this is now a big win or whatever, right? Yeah? So what we'll do, we will start doing something. We will start creating a stream. Right. So I am using the control center, this UI, because I'm a UI guy. I mean, I'm an old being the operative word, old Visual Basic programmer, drag and drop, point and click. That whole thing with command line and stuff, yeah. But you can definitely use command line for all this. So ksqlDB has its own CLI that you can do all this from, and you can do a lot more than what you can do in the UI. But I'm just using the UI because I'm a lazy boy. Yeah? So let's take this. We're going into ksqlDB here in my UI. and we are pushing in here in the editor. Whoa, my this statement to create the stream. So this is kind of like what we do in SQL. So create stream, create table. What's the difference? So we're setting up create stream. We're saying what it consists of, and then we're saying run query. Right here we now have a stream that we call stream game events. Cool. And if I were to do this, let's steal some code. We'll talk about what this emit changes is in a second. So here I'm now writing a SQL statement against my stream. All right. So we're saying run query, and no messages has appeared because I've said that I'm resetting my offset to the latest. Yeah. So it will now start listening for new stuff coming in. Make sense? So if I then go in here to my publisher, and I'm clicking yes, and we now have some stuff has come out in the stream. Well, so what? That's not very much. That's almost like the topic. Sure, it is, right? But wait, there is more. So now, what we want to do is we want to look at an aggregate of the score. Remember in the event we had a score field, score property, and now I want to see an aggregate of the score for the various players. Yeah? Kind of where I'm going with this is that stream, that initial stream that we saw, yeah, I could as easily have done that in my C# consumer. But now it's getting a little bit interesting, where we're saying here, create table, select player ID, sum score, etc., right? Because now we're keeping state. So stop that query and run query. And I have a success. Yowza, that's cool. Now, what we can do, I have here a TB score aggregate. We can click on that and then say query table. So now I want to select here from this table. So we run query. Oh, that was also the latest, bummer. Let's see if I can change that. And say run query. Oh, that didn't want to do it, so let's do this. Let's do this then. Let's and now in this table, we now have scores of players popping out. Are we good? Questions about that so far? You, Brew, I have weak knees, I'm old, I can't hear, you gotta come here.
How would you ensure performance? Can you index that database or anything?
Sorry.
That's right. How would you ensure performance when that stream gets really large? How do you ensure, can you index that database?
Okay, so how do I ensure performance? I ensure performance by There we go. I ensure performance by having more partitions, more nodes, etc. So we are distributing out, we are sharding out everything. But it's a very good question. Cool.
So how do we interpret that result set? If you just triggered it like 4 times, is it only showing the results of the latest message as a summation of that player? Or is it going to return all players and all results every time?
So what does this return? So the way I wrote that query, I put emit change, I did select emit changes, which means that for every time we are generating a new score, it will be output. If I go into the table and do a select star from the table, you will only see you will only see 3 entries for 101, 104, and 102. Because the table is a, well, materialized view. So this gives a kind of weird view on things because you're seeing, well, you can see hundreds 102 there because that's just, it's being output continuously.
Right.
I'm aware that exactly once processing is possible in Kafka and in order as well. Is that something you've tried, and do you see any sort of performance drop-offs with it?
So the question or the statement, whatever, is that I have heard about exactly once processing and also in order. Is that something I have tried? Does it impact performance? By default, you get in order due to the whole key and partition. So so let's say that you're partitioning on player ID. Now, the players with the same player ID will always end up on the same partition and will always end up on the same partition in order. For once, exactly once, you need to set some settings which has an impact on performance, but it is not too bad. I don't have any figures to give you, but it is not too bad. We had some other question here. He desperately now wants something here, huh? Yep, fire away.
Obviously, now as we are streaming, I think we require more and more stats. But given that the schema is quite rigid right now in terms of the topic, how do you deal with this?
So again, so the schema is quite rigid,
Yeah,
but
in the topic kind
yeah.
of, right? So given that obviously now you start streaming, you're gonna get more and more stats, or you want to kind of do some analysis on other kind of columns. So how do you deal with this thing? Do you need to recreate the topic all the time, or?
Well, you would ensure that if these are now different event types, so how do you deal with schema, I guess is the question. You would ensure that your events ends up on different topics. You can send different types of events to the same topic, but you would then need to handle it somehow to understand what it is. Right. Why? So if you guys and girls are doing presentations like this and have been doing it online from home for the last 2 years, before you're going out to a conference like this, ensure that your laptop that you're normally using is working. The day before I left to come here, I took my laptop, my normal sort of conf laptop, switched it on, and it was completely dead. So I had to take my work laptop, which has a lot of rigid security stuff on it. So yeah, that wasn't fun. Cool. Right. We are getting very short on time. I know we have some minutes afterwards, but so now we have seen a little bit like this. Now we want to do that example I had. where we want to create a table that we call big win, where we are saying that, and the big win is within a 60-second period. This is just made up figures, right? Within a 60 seconds period, I should have made more than one bet during that period, and I should have a score, a summarized score, aggregated score more than 100. I have set this very, very low to be able to show outputs, yeah? Cool. So let's do that then. So create a new table. Create table TB big win, run the query. Whoa, why didn't this work for? Oh, player ID 2. In a second, I'll tell you what I did here. Cool, that works, kind of. Let's query the table. So we actually now picked up that we had one player that within a minute had done this. Let's do a couple of more players here. So that was 103, 101, 100, 104, 104, 104, 104 should 102, etc. So cool. We now have an output here of players that matches my requirement. Now you're saying that, well, this is cool, kind of. What do I do now? I mean, I can't run this in production, right? That's probably not how I want to do it. I want to act upon that. I want to have a system that gets this, like we had in one of the slides where we had the green arrow coming down to the lower right-hand side. I want to have that. The cool thing, the interesting thing, is that these tables, they are being backed by topics. So if we go in and looking at, so here I now have a topic, TB big win, yeah, and if I look at messages, if we're starting at offset 0, I can now see here how messages has come into the topic. And as I now have a topic, what can I do? I can consume. So the last thing we will do, I have 1 minute left. Well, I'm sorry, I'll go over a little bit, just a little bit. Just because I'm such a nice guy, or not. So, let's do that. So now we're saying that the topic is TB big win. And then what we do is rebuild .NET build. So I changed in the code to read from that now TB big win topic. Cool. So we're saying close and .NET run. Oh, and I've said that start to consume from the beginning. So let's do this. And there we go. Cool. So it has now picked up here some players that had a big win. If I now continue to run, we should see, and we are seeing, how now big win players are popping up, how I am consuming, and now I can take, my application can now take that and do stuff. Cool. That was more or less it. Well, there are a lot more, but we have seen all this. So Kafka, distributed streaming platform. Stream processing is when we're handling events messages, and ksqlDB lowers the thing. ksqlDB is awesome. No ifs and buts about it. And it sits in a sweet spot where we do not want to push data into a database, right? Because we want to act upon thousands and thousands of messages per second in real time without having too much latency, i.e. push data down to the database and retrieve it back from the database, right? Once again, thanks questions, and there is the feedback. So, boys and girls, thank you so much.